Bucka, 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 bucka. Ha ha. You know the deal.
Let's take a look at a couple of examples of solving equations where we have more than one thing to get rid of, to get x by itself, or whatever variable it might be by itself. So this is a case here where you're asked to solve this equation, and the goal, as always, is to isolate the variable, to get, in this case, x by itself. So the question you have to ask yourself is, well, what do I have to get rid of here to get x by itself? And in this example, we actually have two things we have to get rid of. We have to get rid of times 2, so that's what 2 is doing to x here, is multiplying by 2, and we have to get rid of subtract 3. Now, when you have more than one operation to deal with, usually the way you remember which one to deal with first is BEDMAS. But when we're trying to isolate the variable, if you remember from the previous examples, we're always doing the opposite of what's there to get the variable by itself. Similarly, we follow the opposite of BEDMAS. So if we're dealing with a question where we have more than one operation and we're trying to isolate the variable, we deal with the operations in the opposite order of BEDMAS. So in this case, we have multiplication and we have subtraction that we have to get rid of. Well, if we're going to follow the opposite of BEDMAS, we're going to start with the subtraction. So that means we're going to get rid of minus 3 first. Well, as we saw in the previous examples, to get rid of minus 3, of course, we add 3. We do the opposite operation. An equal sign is like a balance scale. So if I change the left-hand side at all, I have to change the right side in exactly the same way. The left side is now different because we added 3. So we have to also add 3 to the right side. Now, as with any algebraic equation, if there's any simplifying you can do, if there's any math you can do, you do the simplifying. Minus 3 plus 3 essentially cancel themselves out. So all you have remaining on the left side is 2x. 7 plus 3 is 10. Well, we're not quite done yet because we still have to get rid of times 2. And as we saw with the previous examples, to get rid of multiplication, we divide. The opposite of times 2 would be divide by 2. If we divide the left side by 2, we have to also divide the right side by 2. Multiplying by 2 and dividing by 2 essentially cancel themselves out, and we're left with the final answer, x equals 5. So we've done it. We've isolated the variable. Now once again, we can check our answer. If we go back to the original equation, we had 2x minus 3 equals 7. If we substitute in our answer here, our answer was 5. So instead of writing an x, I'm going to write a 5. Now, we're not isolating the variable here. We're simplifying. We're just doing the math. So of course, we do have to follow order of operations here. I have to do the multiplication before I do the subtraction. 2 times 5 is 10. 10 minus 3 is 7. So we get the solution 7 equals 7, which is a true statement. If this is a true statement, you have a pretty good idea that this answer is correct. So here's another example where, once again, we would be asked to solve. If we're asked to solve an algebraic equation, our goal is isolate the variable, get x by itself. So once again, we have to ask ourselves, well, what do we have to get rid of here to get x by itself? And mathematically, what I see is with x is plus 4 and divided by 2. So those are the things that we have to get rid of. We have to get rid of adding 4 and dividing by 2. Well, since we're doing the opposite of what's there to isolate the variable, we also follow the opposite of BEDMAS. So I'm going to deal with addition before I deal with division. So how do we get rid of adding 4? Well, we do the opposite of adding 4. And the opposite of adding 4 would be subtracting 4. If we subtract 4 from the left-hand side, we also have to subtract 4 from the right-hand side. Now we have a case where we can simplify. Plus 4 minus 4 cancels itself out, makes 0. X over 2 plus 0 is just x over 2. And 9 minus 4 is 5. We're not quite there yet because we haven't isolated the variable. What's still with the variable is divided by 2. To get rid of divided by 2, we multiply by 2. If I multiply the left side by 2, I have to multiply the right side by 2. Multiplying by 2 and dividing by 2 cancel themselves out. In this case, they make 1. 1 times x is just x, and 5 times 2 is 10. Once again, we can check our answer if we go back to the original equation, which was x divided by 2 plus 4 equals 9. We take our answer that we got to that, sub it in, so instead of writing x, we write a 10. Now, of course, we're just doing the math, we're simplifying, so we have to follow BEDMAS, so we have to do the division before we do the addition. 10 divided by 2 is 5. Still have to do the plus 4, and 5 plus 4, of course, is 9. So we, once again, have a case where when we do all of our simplifying, the left side equals the right side, so we can assume that this is the correct answer for x. So here's another example where, once again, we're being asked to solve this equation. So the goal here is to get x by itself. Now, we've seen a couple of these examples already, so hopefully by now you understand that what we have to get rid of here is times negative 5 and subtract 4. By the time you get into grade 9, you've seen these types of questions quite a few times, and you know that to get rid of minus 4, you're going to add 4. And if you add 4 to one side, you have to add 4 to the other side. Mathematicians kind of saw a bit of a shortcut here. We know that we're going to add 4 to both sides, so another way to look at this is, what we're doing is we're taking minus 4 and bringing it over to the other side. Now we know to get rid of minus 4, we add 4. And if we add 4 to the left side, minus 4 plus 4 makes nothing, which means we're just left with negative 5x. And if we add 4 to the left side, we also have to add 4 to the right side. So this is a little bit of a shortcut that most grade 9 teachers will allow, in that we look at this like we're moving minus 4 over to the other side. And as you can see, if we move it over to the other side, it becomes plus 4. So we are allowed to move entire terms across the equal sign. And when we do that, they change to their opposite sign. So minus 4 becomes plus 4 in this case. Well, once again, here we have a case where we can simplify. And we can simplify what's on the right-hand side. Negative 14 plus 4 is negative 10. Now, we're not quite done because we still have to get rid of times negative 5. Now, we cannot move this minus 5 over to the other side because it's multiplying by x. We could move this whole term across the equal sign if we wanted to, but that's not really going to help us here. That's just going to move that over there, and that would become plus 5x. That doesn't help us. So what we still have to get rid of here is times negative 5. To get rid of times negative 5, we have to divide by negative 5. We still have to do the opposite operation for multiplication and division. So if we divide the left-hand side by negative 5, we have to divide the right-hand side by negative 5. By now we've seen this enough times to know that these cancel each other out. We're just left with x. Negative 10 divided by negative 5 is 2. And once again, you could check your answer to see if that is correct. Now that we've seen a couple of examples like this, I want you to go ahead and try a couple. So what I'd ask you to do now is pause the video and try to solve each one of these equations. And in your solution, show each of your steps in terms of how you're trying to isolate the variable. When you've got your solutions, go ahead and press play, and you can check to see if your answer is correct. Okay, so let's take a look at the first one. So with the first one, again, just like any algebraic equation, when we're asked to solve it, our goal is to isolate the variable. So we have to get x by itself here. So we have to get rid of times negative 3 and adding 1. We're going to follow the opposite of BEDMAS when we're isolating the variable, so we're going to get rid of plus 1 first. Now a little bit of a shortcut here is, if you want to look at this like you bring plus 1 over to the other side, what we have remaining on the left-hand side is negative 3 times x. If we bring plus 1 over to the other side, it becomes minus 1. Now we've got a case here where we can simplify. The left-hand side stays the same. Nothing we can simplify there, but 7 minus 1 is 6. We're not quite done yet because we still have to get rid of times negative 3. To get rid of times negative 3, we divide by negative 3. If we divide the left side by negative 3, we have to divide the right side by negative 3. times by negative 3 and divide by negative 3 cancels itself out. It makes 1. 1x is just the same as x, and 6 divided by negative 3 is negative 2. For the next one, again, we've got two things that we have to get rid of. We have to get rid of plus 4 and divided by 2. We're going to follow the opposite of BEDMAS, so we're going to get rid of plus 4 first. What do we do with that? Well, we can bring it over to the other side. So if we bring that over to the other side, we've got x over 2 on the left-hand side, and then on the right side, we bring that plus 4 over to the other side, it becomes minus 4. We've got a case here again where we can simplify. 10 minus 4 is 6, so on the right-hand side we have 6. We're not quite done here. We still have to get rid of divided by 2. To get rid of divided by 2, we multiply by 2. Whatever we do to the left side, we have to do the same thing to the right side. Multiplying by 2 and dividing by 2 cancel themselves out, and 6 times 2 is 12. If those were the solutions that you got to these two questions, congratulations, you now have a firm understanding of how to solve multi-step algebraic equations.